Oh my goodness. There we go. All right, so the value of its perimeter equals the value of its area. Okay, so we want perimeter equaling area. So let's start with perimeter. Okay, let me pull this over here just a little bit. Okay, so perimeter. So we're just adding up all the sides, right? So we have 6 here. And we know these 3 pieces put together have to be 6, right? So we have 6 and 6 is 12. So then we just need these 2 little pieces. That's 13 and 14. But then we have these x pieces. So let's write down our whole number of 14 first. So we have 14 for the perimeter plus. Then we have these 2 sides. This side is x and this side is x. So what would we have to add to our 14 expression? 14 plus 2x, right? So we have 14 plus 2x. That's my perimeter, okay? For area, have a quick 1-minute conversation with your groups about how, come up with some kind of plan on how we could find the area of this weird shape. Go ahead. What did you guys come up with? Yes, sir, Sam.
14 plus 2x equals y.
You mean y for the area? No. We need some actual math that we could do to find the area here. What's weird about this shape? It caves in, or we have this little like cutout area right here, right? So we have this little cut. What is happening? We have this little cutout area right here, right? Okay. So is there a way that we could deal with this cutout area that would be kind of easy? Fill it in. So what if we find, that's an interesting idea, what if we find the area of this entire shape acting like this piece is filled in? What would the area of this entire shape be if we had this little piece filled in?
That side would be 6.
Yeah, length times width. So what's 6 times x? 6x. But then we want to take out the part that we quote-unquote filled in. What's the area of this little box?
2.
Just 2, right? 2 times 1 would just be 2. So 6x minus 2 would be our area there. Okay, if we look at it, and I saw some of you cutting the figure up, and that is one good strategy. It's kind of a hard one to use here because we're not given a whole lot of information. But I think the easier strategy is find the big thing, cut out the piece. Okay, so now we have an equation where we have perimeter, equals the area. So let's go ahead and solve. So as we talked about on warm-up, it is super important for us to recognize when our variables are on the same side, and we should simplify, versus when our variables are on opposite sides, and we should do opposite operations. So are our variables on the same side or opposite sides here? Opposite sides. So we need to do opposite operations. It 100% does not matter which side we take variables to. So which side would you guys like to take my variables to, the left or the right? The right. I heard more right, so we'll do that. So my opposite operation to get rid of my 2x is just going to be subtract 2x. That's gone. I'm left with 14 equals 6x minus 2x is 4x. Bring down my minus 2. Okay, one thing that is important is wherever you take the variables to, you have to take the numbers to the opposite side. So it does not really matter which side you take the variables to, but once you take them to a side, make sure to take the numbers to the opposite side. So since our variables went to the right-hand side, our numbers need to go to the left-hand side. So I'm going to add 2 over to this side. We have 16. Oh, it looks like a negative 12. All right, add 6. So we have 16 equals 4x. Last step, divide by 4. We get x is 4. Okay, so we get x is 4. Okay. All right. So down at the bottom, there are some important steps down here. Okay. You can see that we always want to do step 1 and 2 using the distributive property to get rid of any parentheses and combining like terms. Those 2 steps are what we called, or what we referred to last time as same side, simplify. Right? Those two steps are what we refer to as same side simplify. Because those are the two steps that we're doing stuff on the same sides. Once we get done with those two, then we move on to solving. So we collect the variables to one side, we collect the numbers to the other side. That's all of my opposite operation stuff. Okay, that's all of my opposite side, opposite operation. So always start with same side simplify. Get rid of parentheses, combine like terms, and then starting with step 3, you collect all your variables to one side. It doesn't matter which side, but whichever side you take variables to, you got to take your numbers to the opposite side and then go from there. Okay? All right, let's look at some examples on the next page. Okay. Since we did one that was pretty similar to 1 and 2, let's just jump straight to 3. Okay, because we all love fractions, right?
Yeah, we do.
It's not really that scary. Okay, so remember, anytime I'm doing a fraction times a whole number, it's multiply the tops, divide by the bottom. So multiply, so somebody grab your calculator, make sure it's handy. So we have 3 times 48. So what's 3 times 48? 144. Okay, so then we have 144 and divide by the bottom. So what's 144 divided by 4? 36, yep. Okay, so that piece is 36. See, it wasn't that bad. Now let's do the same thing with the 16. 3 times negative 16 would be negative 48, right? And then divide by 4 would be negative 12. So minus 12x equals, and then the other side should be cake, right? 4 times 4 is 16. 4 times 2x is plus 8x. So I've distributed. Is there any other same side simplify I can do? No, there are no like terms I can combine that are on the same side of the equal sign, right? So now my variables are on opposite sides. I personally like to keep variables positive. Okay, you don't have to follow that same thing if you don't want to, but I personally like to keep variables positive. In order to keep my variables positive, it would be smarter for me to add 12 to both sides. Okay, so I'm going to add the 12x to both sides. And again, if you wanted to take all the variables to the left, you're more than welcome to do that. So I'm left with 36 equals 16. 8x and 12x makes plus 20x. Whichever side I take variables to, I have to take numbers to the opposite side. So I'm going to subtract 16. If you did it the opposite way, that's fine. So I get 20 equals 20x. I divide, and I get x is 1. And regardless of which side you take variables to, guys, and numbers to, you're obviously going to get the same answer, right? The answer is the answer is the answer. That doesn't change based on the order in which you solve it. Okay? Okay, so just like we talked about earlier when we were talking about the rubric, remember 3 was mastery. Mastery means I can do it independently with very little prompting from a teacher or peer, and I make few mistakes. That's a 3. A 2 would be near mastery. So near mastery means that you may need a little bit of prompting from a teacher or peers. You may make some mistakes as you're doing this, but you can mostly do it independently and you're really close to mastery. That would be near mastery. That's a 2. A 1 is needs improvement. So you have the basic concept of what's going on, but you need some help getting through the problems from either a peer or a teacher. You may make several mistakes as you're going through it, which is not a bad thing, right? But that's where a lot of us are in the beginning stages of learning something, and that's okay. So a 3 is mastery, 2 is near mastery, 1 is needs improvement. A 0 means you have no idea what's going on. On any kind of assessment, if you're ever marked as a 0, that means you either left it blank or you completely wrote stuff that makes no sense towards the problem. Okay, so 3 is mastery, 2 is near mastery, 1 is needs improvement, 0 is no evidence. Okay? So several times while we're doing lessons, I will ask you guys for a comfort level. Okay, and a comfort level is very simple. You're going to hold up however many fingers you feel like you are. So if you feel like you have mastered the topic, you're going to hold up 3 fingers. If you feel like you're near mastery, you're going to hold up 2 fingers. If you feel like you need some improvement, so you have the basic concept, but you still need some practice, you still may need a little bit of coaching from peers or a teacher, you would hold up a 1 finger. If you have no clue what I'm talking about, you would hold up 0 fingers. Okay, and it's not like a loud and proud, you got to tell everybody where you're at. It's just a way for me to look out and see what you guys are, to see if there are individuals I need to help, or if I see a bunch of 2s and 1s, maybe I need to come back and revisit something and maybe reteach a little bit. Okay? All right, so go ahead and give me your comfort level. Where do you feel like you're at right now with this? Okay, 3s and 2s. That's good. Okay. Okay, let's go ahead and try these whoa, zoomed way out. Let's try these numbers 5 and 6. Try these number 5 and 6 together with your groups. Go ahead. Okay, guys, you can go ahead and check your answers on the board for number 5. And just because you did not follow the same path I did does not mean you are wrong, right? We can arrive at the same answer in a different way. Generally, what I show you is the most efficient way, but that doesn't make it the only correct way. So on number 5, 2q plus q is 3q, so I combine my terms first. Then I start doing my opposite operation. So I bring variables over to the left, numbers over to the right, divide, and I end up with q equals -4. Any questions there? Okay, number 6. You obviously have to distribute first to get rid of those parentheses. So I distribute the 2 into the first set of parentheses. On the other side of the equal sign, distribute the 4 into the second set of parentheses. And then I start doing my opposites. Again, in the interest of keeping my variables positive, I subtract 8b over to the right-hand side. Doesn't mean you had to do it that way. So since I brought variables to the right-hand side, I bring numbers over to the left-hand side, divide down, and I end up with b equals 4. Okay, any questions on those kind of problems? All right, let's look at special cases. Okay, so these are special for a reason. Weird things are going to happen, but I'm going to trust you guys to try these. So let's go ahead and let's just do 8 and 9. So don't do 10 or 11, just do 8 and 9 together with your groups. Go ahead. Okay, all right, so let's talk about 8 and 9, okay? Guys, how many solutions did all of the ones that we did on the front have? Just one single solution. Okay, so normal problems, when we solve them down, they get x equals a certain number. That's how you know we get one solution. That's a normal problem, okay? Let's look at the weird ones here. So let's look at 8. So I distribute first, right? I get 24s plus 6 times 12 is 72. On the other side of the equal sign, 8 times 3 is 24s. And what's 8 times negative 14? 80, 122, 112. Okay. Okay, I need to do an opposite operation to bring my variables to the same side, so I subtract 24s. What's 24s minus 24s? Gonzo, right? It's gone. It's completely disappeared. So I have 72 equals. On that side, 24 minus 24 eliminates. I get 72 equals negative 112, okay? So anytime we have something that looks like this, okay, when we are having variables completely eliminate, that's when we know we're having a special case, okay? And the only question you have to ask yourself is it true? So does 72 equal negative 112?
Nope.
It doesn't. So since it does not equal, that would be a case of no. That's an ugly N. There you go. No solution. Okay? So if it's not true, once the variables eliminate, that is no solution. Let's look at 19. Is there anything we can do to simplify the left-hand side on 19? Or excuse me, on number 9? No, there's not. So I leave the 16f plus 24 alone. On the other side, 8 times 2f is 16f. 8 times 3 is plus 24. And now I can go ahead and do my opposite. So I subtract 16f for both sides. So that's gone, and that's gone. I'm left with 24 equals 24. Is that true? Yes, it is. So this is called infinitely many solutions. You could also say all real numbers for that. Basically what this is telling us, guys, is on number 8, any number you could imagine to put in for S would not make the equation true. There's absolutely nothing that I could plug in for S that would make that equation true. That's what no solution means. On number 9, infinitely many solutions means absolutely any number I could think of. If I plugged it in for F, the equation would be true. Anything. Anything you can imagine. Any decimal fraction, any number like that, you could plug in for F and it would work. Okay? Okay, we have one more problem down at the bottom. Most of the word problems that we've looked at so far, we were looking for some kind of total, right? To make it total equals everything else. This one is not so much that way, okay? So it says, unfortunately, a water pipe has started a leak in your basement. Plumber Joe charges $45 to find the leak and $75 to fix it, $75 per hour to fix it. Plumber Bobby charges $60 to find the leak, but only $67.50 per hour to fix it. So let's think about this for a second. What does your gut tell you? What's your gut tell you? Plumber Joe or Plumber Bobby?
Joe.
Yeah, what do you think? Joe? Why do you think Joe? Okay, so he's cheaper up front to find the leak. Would anybody say Bobby?
Depends how long it takes.
It does depend how long it takes. Why would it be beneficial to go with Bobby?
If it takes a really long time.
Okay, if it takes a really long time, because his per hour charge is cheaper, right? So one of them is cheaper to find the leak. The other one, that's the upfront charge, right? The other one is cheaper per hour to fix it. Okay, so what we want to do is find the number of hours it would take to make the cost the same, because if we know that number of hours to make the cost the same, we can estimate how long it's going to take and figure out which plumber we want to go with. Okay, so if we want them to be the same, what does same mean in algebra? Equal. Okay, so I want to figure out what makes Joe equal to Bobby. Okay, I want to figure out what makes Joe equal to Bobby. And the thing that we're trying to find is hours. So we're going to say X is the number of hours. All right, so let's look at Joe first. What does Joe charge you?
45 to find it.
Okay, $45 to find it. How many times did he charge you that $45? Just once. So 45 plus, what else does he charge you? 75 per hour. So 75x. Okay, then that's equal to Bobby. So Bobby charges $60 to find the leak. The leak plus, sorry, I'm struggling. $67.50 per hour. So now I'm ready to solve. So I get, I missed an X, didn't I? 6750X. So I want to bring variables to the same side. So I'm going to subtract over the 6750X. So I have 45 plus 750X equals 60. Okay, I do a second opposite operation to bring the numbers to the same side. So subtract 45. So I have 750. Let me pull this up some. So I have 750x equals 15. I divide by 750. And I end up with x equals 2 hours. Okay, so knowing the 2 hour mark is useful, but let's get down to the nitty gritty real question. So what if they say, hey, it's going to take 3 hours? If they say it's going to take 3 hours, who would you go with? Yeah.
Do you want to know who you would go with?
Yep.
I didn't figure that out.
You had to figure that out. Okay. Yeah,
What? I was stretching.
just stretching.
I didn't know.
So if we go to 3 hours, let's think about this. 2 hours is when they're going to be the same. If you go above that at all, you're going to want which person? The person that's cheaper up front or the person that's cheaper per hour? Cheaper per hour, right? So if you know they're the same at 2 hours, if you go above that, you're going to want the person that's cheaper per hour, which is Bobby, right? If you go less than 2 hours, you're going to want the person that's cheaper up front, which would be Joe. Okay? So that's why it's important to know the 2 hour mark is where they're going to be the same. Because after that, you're just going for per hour charge, right? Before that, you're going to go for the upfront charge. Okay, any questions there? So all of our word problems that we're looking at right now kind of fall into two main categories. One of them is going to kind of be a total equals everything else. Okay, so we look for some kind of total and how that total is spent or used or calculated. The other type, this type, is when we're comparing two different options and we want to know when they're going to be the same. Okay.